Can you hear me, Nathalie?
Yes, I can hear you, and you?
So the floor is yours. We hear you very well.
Okay, I will share my screen.
It's coming. Very good.
So, it's okay for you?
Yeah.
Hi everyone. I'm sorry I can't be with you in person today to attend this round table, but I wish you a great meeting. Today I will present you the research work we are doing at the National Museum of Natural History in Paris, in France, to improve the state of the urban ecosystem in its functioning and thus the services for the benefit of biodiversity and city dwellers. As you know, cities are particular habitats, very hostile for many plants and animals, but not really they cooperate. In a number of species, we can find a significant number of plants, animals, and all other forms of living organisms. And these species form the ecosystem, the urban ecosystem, which is more or less functional, depending on the species present and the interactions they have with each other. This urban ecosystem, like the other ecosystems of the world, provides a number of services, including cooling during heat waves, prevention against floods, regulating air, water, and soil pollutions, and providing pleasant spaces for recreational activities. Nature-based solutions have the objective to enhance resilience, sustainability, and quality of life in cities by integrating ecosystem services into urban planning. Our guide is on how to use NBS to enhance ecosystem services in cities are following: assessment and planning, the ecosystem services, the development of green infrastructures, the ecological restoration, and community engagement and education. The assessment and planning of ecosystem services the objectives are to identify the ecosystem services that are the more critical for the city. For example, heat waves, stormwater management, amenity, and so on, and to assess the current state of these ecosystem services and identify areas where improvements are needed. In this context, we have worked on the research of new spaces to vegetate in the city of Paris, with a focus on rooftops. We wanted to know which roof could be greened in Paris. For that purpose, we used a software called GraphAb, and it helped her to compare the potential green roof role to connectivity in relation to other urban green spaces, to specify the green roof's contribution, to explore the influence of the building height, and finally to assess the impact on connectivity of the simulated greening new roofs. Here you have a map of Paris with, in blue, the places where we could vegetate rooftops. At a local scale, green roofs would have a dispersion flux function for animal and plant species. At a large scale, this vegetation can improve the global connectivity through the connections they provide among other green spaces. We also worked on a very particular space, which is the base of the alignment trees, of the street trees. We thought that they could strengthen the urban green network in creating habitat corridors and green spaces to connect fragmented habitats within the city, and thus to facilitate the movement of wildlife and promote genetic exchange among populations. Here you have a district of Paris where we inventoried all the tree bases of the district. All the black dots are the trees that we inventoried. And we do that from 2009. And what we found is that plants use tree bases as corridors, and particularly in dense districts. The species that are favored are long-lived seed species, able to form a seed bank in the soil, and they can establish in the whole district thanks to the tree bases. And what we saw also is that weeding disrupts the population dynamics of the plants that are the pullers. So here you have the plants of Paris, that an example of the 200 plants that are living in the tree bases of the district of Paris. And what we saw is that tree bases can provide corridors for species depending on their biological traits, depending on the characteristics of the tree bases, and also on the structure of the district and where the green spaces are located. We also tried to find to develop new infrastructure, new green infrastructure, and the opportunity and the way to better vegetalize the walls and buildings. We are participating in tests for construction materials enabling planted or spontaneous vegetation to grow. Here you see a small building built with 3 types of bricks containing substrates that allows plants to germinate and to grow. So this is a work at the interface between urban ecology and urban architectural design, and it gives essential elements for various stakeholders in the construction industry. We also worked on the roof tops with the objective to find new habitats for animal species, to favor interactions among species, to benefit for city dwellers and through the aesthetic value. And we saw that the depth of the substrates influences the quality of the biodiversity that establishes on rooftops. And we saw also that mixing ornamental and wild plant species improve the ecosystem functioning and preserve also the aesthetic value of the vegetal communities. Here you have the design of an experiment we are conducting on rooftops of Paris. Storing the urban ecosystem involves also to find new vegetated spaces, and particularly in a district where all the surfaces are asphalted, cemented, or concreted. A new research team involves evaluating the reconquest of the surfaces, the vegetative surfaces through desertificialization the areas. In Paris, many schoolyards have been desertificialized, and it permits to create islands of coolness, educational spaces for reconnecting pupils and residents with nature, and to improve water infiltration into the soil. And so, one of our research programs consists in see how biodiversity come back in the schoolyards after desertificialization. For our part to community engagement and education, you have to know that at the National Museum we develop citizen science programs on butterflies, bats, or birds. For plants, we developed a program called Sauvage de ma rue. It means in French, wild plants of my street. And this program has two objectives. First, to collect data on the flora of the streets, and two, raising awareness among city dwellers about biodiversity preservation. We propose a very simple protocol. Observers have to choose a street, identify the species, list them, noting in which types of habitat they find them, enter the data online using a user-friendly software, and this program received a very great success. On this map, you can see the number of streets that have been inventoried by benevoles. So we had about 25,000 streets inventoried during 10 years. And with them, we analyzed the characteristics of the plant communities in cities in order to give better advice to urban managers. Here you can see that when we are far from the city center, we find more species in the streets than in the city center. So, a way of using nature-based solutions is to try to mimic natural ecosystems to recreate functional ecosystems in cities. And this is to enhance ecosystem services, to improve resilience to climate change, and to create more sustainable and livable environments for residents and wildlife alike. I would like to thank all the urban teams of my laboratory, CESCO, all the students, and particularly the PhD students that made this amazing science. And I hope it will be possible to exchange with my Singaporean colleagues on that topic in the future. And I thank you for your attention.
Thank you very much, Nathalie. So I will let information back to you. Thank you, Nathalie. Okay. So.